Hello. In this video, we are going to go over power rule integration. So we're going to integrate the power rule. In another video, we have gone over the derivatives of the power rule. This one, we are going to integrate the power rule. So let us go over the basis of the power rule first, just like we did in derivatives. First, I have my integral symbol, my antiderivative of x to the power of n. What happens is, what we need to do is we know when we're deriving, right? When we are deriving this, we multiply n to the front, the exponent to the front, and subtract by 1 from the exponent. When I'm going to integrate, we're actually going to do it the opposite way, the exact opposite way. When I'm integrating, I'm going to add 1 to the exponent and divide by that new exponent. That is how we're going to solve these problems. And then at the end of it, we're just going to do plus c. So one more time, if I'm integrating x to the n, we add 1 to the exponent, then divide that term by that new exponent. And then we will add a c to finish it off. So let's jump straight into it. We're going to take the integral of 12x squared dx with respect to x. First thing we're going to do is bring the coefficient out to the front. We're going to deal with that at the end. And we're going to put our brackets, because 12's out. We're going to have the integral of x squared dx. Next, we're going to apply the integral. First, like we just went over above, add 1 to the exponent. So 2 plus 1 is 3. Then divide by that new exponent. We're going to put that in parentheses, bring down our 12 still, because it's still there, add our plus c. Next, we are just going to combine and multiply these two terms. 12 divided by 3 will give us, well, let's just write our cancellation step to make it clear, because we can put 12 over 1. And we see our final answer is 4x cubed plus c. Boom. Let's move on. Same thing here. Our first step with this integration is bring the integration to all of the terms in between. My integration kind of distributes, if you will, right? It's not distributing, it is moving, but it kind of makes sense if you think about it in such a way. So we have, and they all have to share a dx, sorry. Okay, so then now we're going to apply our integrals. We know the -9 is going to stay, so we're going to have our -9. The integral of x squared, add 1 to the 2 like we've done just above. 3, divide by that new exponent. That is that integral of x squared. Next, we're going to move to the next term. This has an exponent of 1. So what we're going to do is add 1 to the exponent and divide by the new exponent. We will then put our plus c at the end. Next is our cleanup step. Put 1 over any fractions and cross cancel anything that can be cross canceled. So we'll see that this turns into -3x cubed plus 5x squared plus c. And that is my final answer. You can also derive these to see if we have it, right? So if I derived this one, you would get 3 times 4, right? Bring the coefficient 3 times, what does this turn into? And we see that's exactly what we have. So that will work for all of them. If we derive this one, we see that's what we get, and that's what we have. So our integral was completed correctly. Let's do a couple more and we can be done. So for these guys, what we see is that the integral, let's put this video, I guess, here. I don't want it blocking that. Well, I have exponents on the denominator. What I'm going to do first is bring them to the numerator by making it a negative exponent. If we recall that trick from exponent properties, this is what we have. So we can bring them all to the top and just putting on a negative, slapping a negative onto those exponents. Next, we're going to put our integral in between all of them. Or we can do a little bit of a shortcut if you don't want to keep putting the integral there. We can just take the integral. However, I think it's important to show because it is a little easier when you don't have to worry about the coefficient. And I forgot my dx for the other one. There we go. So as we see, this is a 15. Let's just redraw that all together. As we see that for the 15, we're going to bring down the 15. We're going to add 1 to the exponent. -4 plus 1 is -3 divided by the new exponent. Plus bring down the 8. Add 1 to the exponent. -5 plus 1 is -4. Divide by the new exponent. Add your plus c. Now clean up your fractions and let's cross cancel. We see this will be, right, this will cancel. Oh, we didn't have to write -1. Cancel to be a 1. So we have a negative over, oh wait, no, that's a negative exponent. My fault. So we have 5 times x to the -3 over -1. So we're just going to put a negative in the front. Plus, and we're going to cancel 2, 1, 2x to the -4. And we're going to have to make that also a negative due to the fact that the denominator is also negative. So that will take that into a -2x to -4 plus c. And that will give us that integral final answer. Last one. First, it is a good idea to rewrite this in a fractional exponent and bring out the coefficient. So I bring out the -5/3, and I'm going to rewrite 3x squared to x to the 2/3. So x to the 2/3 dx. The -5/3 just stays there. It's coefficient, it stays. Then we're going to add 1 to 2/3 plus 1, which is just plussing 3/3, right? Because you have to times 3 times 3. Have to have the same denominator. We get 3/3. We see this is 5/3. X to the 5/3 divided by 3, divided by the new coefficient plus c. We need to keep cleaning this up because when I have a fraction of the denominator, we know we have to multiply the top and bottom by a reciprocal. 3/5, 3/5, which this will then cancel. We'll have -5/3 times -3/5. No, positive 3/5. That's me mistaking a dot for a negative sign. Positive 3/5 x to the 5/3 plus c. As we can see, these will cancel. We have negative x to the 5/3 plus c as our final answer after integrating. So as you can see, these can be quite simple and fast as long as we can break it down into power rules from exponents on the denominator, make them negative, bring them to the numerator, exponents with roots involved, use fractions involved with those exponent properties in order to properly do the power rule. As you can see, it makes integrating much easier. If you have any more, I just realized the comment section doesn't work, but if there's anything specific you would like me to make a video on, please feel free to send me an email. Hope everyone has a great day.